Hey everyone, welcome back. Today we're going to look at the Euclid module inside Groovebox Advanced. Euclid generates rhythmic patterns using Euclidean rhythms. It distributes a number of hits as evenly as possible across a number of steps. It's a classic technique for generating musical patterns that show up in traditions all over the world. And it's a great way to get interesting rhythms going without manually programming every step. Let's start with a fresh Groovebox Advanced. I've got a clock D module from Impromptu connected to the clock input using the clock 1 output. Now let's open up the patch. I'll select the kick track and double-click the header to open its patch. What you see is the default signal chain. Step trig goes to trig sample goes to output. Step trig fires a trigger whenever the sequencer hits a step assigned to this track. Trig sample plays a sample. Output sends the audio out. Here's what we're going to do. We're going to replace step trig with a Euclid module, and instead of using the built-in sequencer to decide when this track triggers, we're going to feed it a separate clock and let Euclid generate the rhythm. First, delete the step trig module. Select it and hit delete. Next, add an inputs module to the patch. Find it in the module browser on the right and drag it onto the canvas. The inputs module gives you access to the 6 CV inputs on the Groovebox Advanced panel. Whatever signal you patch into those jacks on the outside shows up on the corresponding output of the inputs module on the inside. Now add a Euclid module the same way. Drag it from the browser onto the canvas. Before we wire anything up inside the patch, let's go back out to VCV Rack and set up the external clock. On the clock D module, take a second output. I'm using clock 2 and patch it into the CV1 input on the Groovebox Advanced. Now here's the important part. Set this second clock to run faster than the main clock. I'll set clock 2 to run at 4 times the rate of clock 1. This gives Euclid more pulses to work with so it can subdivide the beat. Now back inside the patch. Wire the inputs module's output 1 to the clock input on the Euclid module. That faster clock is now driving Euclid's internal step counter. Then connect Euclid's trigger output to the trigger input on the trig sample module. And trig sample is already connected to output, so our signal chain is complete. What we've done here is essentially bypass the normal sequencer for this track. Those step buttons down below the display, well, they don't matter for this track anymore. Euclid is deciding when the triggers happen based on its own internal pattern and the clock we're feeding it. Click on the Euclid module to select it. Its parameters will appear in the panel on the right. There are 3 knobs: hits, steps, and rotation. Steps sets the total length of the pattern, how many clock pulses make up one full cycle. Hits sets how many of those steps get a trigger, and rotation shifts the whole pattern forward by that many steps, changing where the hits land within the cycle. Let's start simple. Set steps to 8 and hits to 3. What you'll hear is 3 triggers spread as evenly as possible across 8 steps. That's the core idea behind Euclidean rhythms. The algorithm distributes the hits so there's maximum spacing between them. With 3 hits in 8 steps, you get hits on steps 1, 4, and 6. That happens to be the Cuban Tresillo rhythm. Try changing hits to 4. Now you've got 4 evenly spaced triggers in 8 steps. That's a straight 4 on the floor pattern. Bring it to 5 hits in 8 steps, and you get the cinquillo pattern common in Afro-Cuban music. Now try the rotation knob. Rotation doesn't change which steps are hits relative to each other. It shifts the entire pattern around the cycle. So, if your pattern starts on step 1, a rotation of 2 moves the whole thing, so it starts on step 3 instead. This is great for getting the same rhythm to hit on different parts of the beat. Try cranking up steps to something like 16 or even 32. With a higher step count, you get longer, more complex patterns before they repeat. Set steps to 16 and hits to 5, and you'll hear a pattern that takes a full bar to cycle through. Mix in some rotation, and you can land on some really interesting grooves that would be tedious to program by hand. And remember, the clock rate matters here. Because we're feeding Euclid a faster clock, 4 times the main tempo, a 16-step Euclid pattern fits into 4 beats of the main sequence. If you change the clock multiplier on clock D, the pattern gets faster or slower while keeping the same rhythmic shape. So that's the Euclid module. Feed it a clock, set your hits and steps, and it generates rhythmic patterns for you. The key thing to understand is that when you use Euclid this way, with an external clock through the inputs module, you're taking rhythm generation out of the step sequencer's hands and letting the algorithm do the work. The step buttons for that track are effectively out of the picture. It's a different way of thinking about rhythm inside Groovebox Advanced. Instead of clicking steps on and off, you're dialing in ratios, hits to steps, and letting the math create the pattern. Combine it with different clock rates, and you can get a lot of rhythmic variety with very few controls. Thanks for watching, and I'll see you in the next one.